Okay, classic question. Here there are two main rules to apply. The first thing that we notice is that this is an expression, is a polynomial fraction, and also there is I, the imaginary part of a complex number. So here again, we need to apply two information. The first kind of things that we will do whenever we have any type of polynomial fraction and we want to find an equivalent is trying to sort of simplify my denominator. Specifically, the main reason why we're doing this one in this case is because we have I. So we always try to get rid of the I at the denominator, as we always try to get rid of any square root or any root in general from the denominator. To do that, there is one simple thing that we need to do, which is using the special products. Specifically, we are going to deal with the special product of addition and subtraction. So remember, we know that we have that A plus B, then multiplying A minus B will be equal to A to the power 2 minus B to the power of 2. That's exactly what we are trying to achieve. Why? Because whenever we have I to the power 2, this one will go away, right? So we will multiply this fraction by one value that is basically of the second part of the special binomial, which is going to be for us, in this case, 8 minus 2i. But since when this one is an expression, we need to keep this one as it is. So we will multiply also on the numerator by the same value. Basically, what we are multiplying by is 1. This fraction represents 1. We are just expressing in a different way. So if we do this multiplication, what we obtain? Well, on top, we have the multiplication of two binomials. So we will use the FOIL method. We will multiply 3 by 8, which is 24, 3 by negative 2i, which is going to be 6i, negative 6i, minus 5y, minus 5i, then multiply 8 is going to be minus 40i, and then negative 5i by negative 2i is going to be plus 10i. What's going to happen in the denominator? Well, we were looking for this case, and that's what we obtained. So we will have 8 by 8, which is 64, and 2i, the multiplying negative 2i, which is going to be negative 4i to the power of 2. I forgot this power 2 on top of it. Also, that one is to the power of 2. Now, complex numbers. There are a few rules to remember. And one of it is the fact that I to the power of 2 right here can be changed right away to negative 1. Remember all the proving that regarding the complex fraction, you can see it in the previous videos regarding radical. But in this case, because of it, we can simplify all that by 24, at the moment, stays as it is. Negative 6i, negative 40i will become negative 46i. And then this one will become 10, then multiplying negative 1. So it's going to be negative 10. At the denominator, we will have something similar, 64, then multiply negative 4, then, 64 minus 4, then multiply negative 1. So it's going to be plus 4. And now we can furthermore simplify, and we obtain, actually, let me write it right here, and we will obtain 24 minus 10 is going to be 14 minus 46i over one number, which is 68, which we can rewrite as 14 over 68 minus 46i over 68. And we can even simplify more now, because 14 over 68 is equal to 7 over 34. And 46i over 68 can be divided both by 2 again, and we will obtain 23i over 34 as well. And well, this is going to be the double simplification we were looking for, because this will be answer C. So, unless we did any mistake with the sign, but I don't think so, that should be the right answer. I hope this video clarified all these question. Again, here we have a question that can be answered by applying two main rules. The rules apply for any complex numbers or radical in general, and any expression that needs to be modified to find an equivalent, something similar, to something that is the same but just in a different form. These one and these one are the two main rules to apply here. I hope this video clarified it.